Hello everyone, this video is about AVL tree and various operations on AVL tree. AVL tree is a self-balancing binary search tree in which each node will contain an extra information called as balance factor. The value of the balance factor is either -1, 0 or +1, and the value of the balance factor would be calculated as height of the left subtree minus height of the right subtree. So to maintain these balance factors, there are various operations on the AVL trees are performed, like rotations on AVL trees. Into this program, I have implemented all the rotations in the subtrees in a AVL tree. Just to have a node over here, we have implemented the node same as that of binary search tree. We'll have a data part where we'll be actually keeping the value. We'll be having left pointer and the right pointer, and an extra thing, that is height, is being maintained over here to check the balance factors. I've also implemented various functions like pre-order, in order, height. Then this is to rotate the right part, left part, and these are all the 4 rotations that we can do on AVL tree. And a balance factor has to be also calculated. So this is just a do while loop to get a menu on the user side. To insert a value into an AVL tree, we will be allocating the size or memory as it was done in BSD, keeping the value in a data part, and left and right part would be null. We are implementing the same thing as we have done in the binary search tree. That is, if we are checking the value is greater than that of the root node, then it has to be placed into the right subtree, and if it is less, then it has to be placed into the left subtree. But at the same time, we will be also checking the balance factor. So balance factor should not be equal to this, and if it is goes around this, accordingly we have to perform that rotation. So this is into the right subtree. So if it is going beyond this, then we have to perform the right rotation, otherwise we will be performing the right left rotation, right rotation here, otherwise it will be right left rotation. If it happens into the left part and the balance factor is moving forward to 2, is greater than 1, in that case we are again checking the value, and then accordingly we will be performing left rotation or will be performing left right rotation. This is the simple function written to delete a node from AVL tree. While deleting a node also we will be checking the balance factor. The node is from the right subtree or the left subtree. If it is so, in the right subtree the similar rotations are to be performed, and if it is from the left subtree, similar rotations are to be performed. This function calculates the height of the tree, and similar way we can calculate the balance factor. So this is rotate right function and this is rotate left function. So accordingly we'll again check, once we have done rotations, we'll be again checking the height. If the height is properly satisfied, then and only then the rotation would stop, otherwise it will happen again and again. So this is the right rotation. Into the right rotation, the arrangement on the nodes on the left is transformed onto the arrangement onto the right node, and that is why we have done it onto the left sub part. Okay, into left rotation, the arrangement of the node so on the right are to be transformed the arrangements to the on the left node, and that is why we are performing this on the right part. Into left right rotation, the arrangements are first shifted to the left and then to the right. So that is why we are performing left right rotation in this way, first left and then right. And when it is right left rotation, into which the arrangements are first shifted to the right and then to the left. So this is how right left rotation is to be performed. This function is written to calculate the balance factor. So every time we are just incrementing the value whenever we are inserting a new node, and here we are just calculating the balance factor as LH minus RS. And these are the simple pre-order, in-order and post-order techniques which will be happening onto this AVL tree. Let's run this program. So let's create a tree. So let's say we want to insert 5 elements into this. Let's say 45, then 67, 34, 23, and then say it's 78. Okay, let's print them. So this is how we'll get the tree with the balance factors. Let's insert something into it. So I've entered 50 and then let's print it. Okay, so you can see that this has been done, and accordingly the arrangement of the nodes are changed by performing the rotations. Thank you.